Hi guys, today we're going to talk a little bit about concentration and what that means, and this is going to make up the next chapter of kind of calculations that we look at. So basically when we talk about concentration, we're talking about how much stuff is dissolved in how much solution. So if you guys recall, if you guys can maybe look at the little pictures on the left and kind of consider this for a second. If we've got a flask, the thing that's doing the dissolving, so I mean you might have something like water, is what we call the solvent. Okay, you might have some small particles dissolved in that water. They might be something like salt. Okay, we call this the solute. Okay, and then the entire thing we call the solution. Okay, so the solvent does the dissolving, the solute is the thing being dissolved, and the overall, the resultant product, I guess, we call the solution. Now, there's two types of solutions that we talk about. We talk about concentrated solutions, where there is a lot of solute dissolved in a solvent, and a dilute solution where there's not much solute dissolved in a solvent. So right now, for our salt solution here, I mean, this, you could consider this, I mean, arbitrarily to be a rather dilute solution. If we added more solute particles, we could say that this solution is now rather concentrated. Notice that the volume hasn't changed at all. Okay, the volume hasn't changed at all. I've just added more solute. Right, so what we're going to have a look at now is we're going to have a look at some different measures of concentration. Okay, so basically we're saying how much solute divided by how much solvent. Okay, now this can be given in different ways. So there's a number of ways that you might be familiar with. So we could have something like grams per liter. Okay, guys, remember that this is the same as writing this. I'm just going to use this notation here. So you could have grams per liter. You could also have, we've been using moles, you can have moles per liter. Okay, you can have percentage weight per weight. So I mean, this is kind of the same as parts per hundred. Okay, so how many grams are in this, right? So this is basically saying how many grams are there per 100 grams of the substance. You can have percentage weight per volume. Okay, so this is saying how many grams are there per 100 mils of the substance. You could also have percentage volume per volume. This is pretty commonly used on packaging in supermarkets. So once we're talking about, once again, we're talking about, so perhaps how many milliliters of our solute do we have in 1,000 milliliters, which would be 1 liter of our solvent. Now, these units don't have to be like these. These are just examples. You could have kilograms per 100 kilograms. You could have kilograms per, per 1,000 units of these, so 10 liters. I mean, it's the same thing. It's just saying parts per, all of these are saying parts per 100. After that, what we have is parts per million. Okay, and then you also get parts per billion. And these are often abbreviated to ppm and ppb respectively. Another way to think about ppm is often it's milligrams per kilogram is a nice way to think about it. Milligrams being times 10 to the minus 3 grams, and kilograms being times 10 to the 3 grams. The difference between, to get from one to the other, we're talking about a jump in times 10 to the 6 or 1 million. Okay, so it's parts per million, milligrams per kilogram. Okay, you can kind of do the same thing with parts per billion, where you go and say, well, okay, billion's 9 zeros, so micrograms per kilogram would be an example of parts per billion. Once again, there's other units that make sense as well. Micrograms is times 10 to the minus 6, okay, and kilograms is times 10 to the 3. So to make that jump this time, okay, we're talking about times 10 to the power of 9, which is a billion. Okay, so these are just some pretty standard units of measure that you might see used. The one that's going to be most important to us in chemistry is going to be moles per liter, because remember that we're usually counting molecules or atoms or reagents and products, we're counting them in moles. We're not usually counting them in grams, but we need to be able to convert between these. So we're going to have a look at some examples of some of these calculations now. So let's just have a look at a quick conversion. Concentration in grams per litre. So let's just do this one. What's the concentration in grams per litre of a solution containing 8 grams of sodium chloride? So our how much is 8 grams of sodium chloride. That's how much. And we've got 500 mils. We're going to make a 500 ml solution, right? So our how much solvent, well, we've got 500 mils, and presumably in this case, we're probably talking about water. Now, it doesn't always have to be water, but in this case, we're talking about water. So what we want to do is we want to divide the amount of solute by the amount of solvent. So we have a look at this. So we can say that our concentration here in grams per litre, if we want it in grams per litre, it's the mass of the solutes divided by the volume of the solvent. This is going to be in grams, this is going to be in litres. So what we're going to do here is we're going to do 8 grams divided by, now 500 mils in litres is going to be 0.5 litres. Now notice that you do the maths with the numbers, but you can also do the maths with the units. So this is this, I can separate this out and I can say that it's 8 divided by 0.5, and then separately it's grams divided by litres. If I divide 8 by 0.5, I get 16 grams. Oh, I get 16, and then if I divide grams per litres, I get grams per litre, or we can write it like this. These are the same thing. I want to show you that you can use the numbers and the units separately and do the maths with those, and that's going to become really, really, really important as we move along in chemistry.